Well, have you ever seen anything like that? The 100 by The Fisher. Monoblocks on the bench for repair. Apparently this one just went out. Could be something simple. Kind of doubt it. We'll see. Welcome to Lancaster Hi-Fi. I'm Stephen Lancaster. And if I've got a bit of a shit-eating grin, have you ever seen anything like these? I don't know much about them yet. I haven't even taken off any of the screens. I haven't looked underneath. All I've done is brought them home from a guy, Jeff, who needed somebody to work on him, or at least one of them. This one apparently just turned off. From what he said, it didn't do so in dramatic fashion. It just stopped. The lights went out. Could be just a short in the heater circuit. Maybe. These are impressive. I'm counting 5 tubes. Rectifier, a couple of big output tubes. I don't know what they are yet. Oh yeah, EL37, which I believe is a 6L6, 12AU7, and 12AT7. Yeah, let's check it out. We've got 2, so we can check out both ends. So on the back here, we just have the power cord, an extra AC outlet, says 350 watts max, and a fuse. I can't remember if he said whether he checked the fuse, so I should probably do that straight away. Over here we've got the usual sorts of things that we'd expect: an input, speaker terminals. We've actually got a selector for output impedance. We've got also a level adjustment. And here's an interesting thing that I've never seen before: a damping factor knob. So let's see, it says up here constant power. Seems to label this point as constant power. And it says damping factor Z-matic. So max damping factor over here, min damping factor over here. Believe damping factor is simply the ratio of input impedance of the next stage, so say 8 ohms, to output impedance of this. Haven't looked at the schematic yet. I do have it, I believe, that Jeff sent it to me. I've got an indicator light for power, probably. Well, let's check out the fuse. It looks fine. Yeah, and the fuse is just fine. Well, that would have been too easy, huh? Let's check out the interior, or at least under the screen. Oh, that rectifier 5V4, which I've never even heard of. It's branded The Fisher. And our other tubes over here. OTK2 87V 6P3C-E, or really 6P3S-E. That's Russian, which means OTK is OTK. 12AT7, just a Sylvania. And the 12AU7, Hammond maybe, probably pulled from an organ at some point. Let's see if the 5V4 is labeled 5V4. Yeah, it is 5V4G. But interesting, the EL37s are not labeled as EL37, nor what I thought EL37s were, which was 6L6, 6P3S, 8705. Well, I'll have to check it out. Don't know if the tubes are the same in the other, but I can't imagine what with these mismatched input tubes that all of them are going to be the same. So we've got a plate on the side, well, not a plate, markings, model 100, got the serial number 105 to what volts? 50 to 60 cycles probably, 170 watts, Fisher Radio Corporation, New York. I think that says 105 to 25, so made to take up to 125 volts, which is interesting for its period, which is long ago, I think. It looks like we can gain admission to the interior by taking off 4 screws, 2 on each side. Now, Jeff gave me both of the units, both the working and the non-working, so that I'd have a reference. It is heavy. It's a lot of iron it's got on it. It's got some other screws. I probably need to take those off. There's a lip here that goes up under this, or this is lipped over the bottom. So I think it's probably held on with these screws. Apparently these were in a console. I don't know if all Fisher 100s were in consoles. Jeff seemed to think that, or seemed to recall, I'm not sure, that they came from a single console. I don't yet know what kind of output power these are supposed to produce. Here we go, that was it. There we go. Not too awfully filthy. Okay, let's check this out. This looks new. I do recall him mentioning something about getting new caps and wondering whether one of them might have been bad, and that might have been the problem with the one that failed, but no reason to believe that any of these are bad. Those look new though. 40 microfarads, 40 microfarads, 20 and 20, 550 volts, 600 volt surge, high grade twist mount electrolytic. Now, the thing that made me say, oh wow, a little bit ago was this, which looks like a big resistor, but I don't know. I mean, it's got how many terminals? 1, 2, 3, 4, 5, 6 terminals on it. Jeff said that this had been gone through, that he had had it worked on, and we can tell because these are new components. You know, the big multicaps are new. We've got new resistors here and here. I don't know if that one's new, but these capacitors, these film caps look new. I mean, you know, relatively speaking. Big old transformers. Let's see what we can see. So power coming in here, going through the fuse. No, going over here. Right, going to through the fuse. And we've got 2 black wires coming out of the transformer. We've got a couple of green wires, or more than one, more than 2. I think we've got 2 and a third. I'm guessing this is the ground wire because it's connected to one of the case lugs on this multicap. So that would make sense. This twisted pair of green wires, I would just figure that those are heater wires. Back to the power transformer. Typically the reds are going to be high voltage, and there's going to be a red and white. That's probably center tap ground, and that does indeed go to one of the lugs on the multicap. And then the twisted pair of yellows go over here to the rectifier, so that's the 5 volt supply. So, nothing too surprising here. We've got 6 volt supply, 5 volt supply, and a high voltage supply. Now here we've got something like a circuit board. Not sure what you'd call that other than a circuit board. It's not a printed circuit board, obviously, but it's a board on which components are mounted. And I can see that these have been replaced by cutting the old leads and soldering onto the old leads. It's not how I generally do it, but it's fine. I'm just anal. I've got a normal sort of electrolytic cap here. Can't read the value. And we've got more components, of course, on the other side. The resistors seem to be original. This is kind of interesting. So it is a copper plated, or at least copper painted chassis. We can see that it's corroded here. And we can see the green from the corrosion of the copper. Copper rusts green. But underneath or further out on the edge here, we can see good old-fashioned rust indicating steel. I'm psyched that I can afford to be picky. Somebody asked me if I fix stuff, and I say, well, yeah. When they say, oh, could you fix my 90s Pioneer receiver? Nope. Could you fix my early 60s Fisher monoblocks? Oh yeah. This is an interesting circuit. We're not to the interesting part. It's off screen. I'll get there in a second. But what do we have here? We've got input level. We've got our AF amp. So these two triodes here are the 12AT7. So we've got our voltage amplification and our phase inverter, they're calling it, but it's a phase splitter. It's a split load. I think that's what you call it, split load phase splitter. Right, so the plates going to the top side, the cathodes going to the bottom side. Cathode always has unity gain, so it's adjusted to where the anode also has unity gain. Basic phase splitter. It does have a phase inverter balance on it. Okay, then we go to a driver stage. That's where the 12AU7s are. Now, I haven't studied this up, so I don't know how much gain those have. 12AU7s have less gain than 12AT7s in general. A lot of the need for the driver stage, I believe, comes in providing enough current to drive the grids of the output stage. So I think the driver is not so concerned with voltage amplification as it is with providing sufficient current. And I don't know, just by looking at it, what the gain of that stage is, but it will be significant. It's got a 2700 ohm cathode resistor shared between the two. Now here's where it gets interesting, is our output stage. So driver stage, and here's our output stage. This is our 6L6Gs or EL37s. Seems that in our amp we have neither one of those things. I'm figuring that what we do have is reasonably equivalent though. Pretty basic as far as this goes. It's pretty high voltage, 460 volts on the anode, on the plate, 465 volts on the screen. Anode typically, again, feeding it 470 volts through the center tap of the primary on the output transformer. Looks like both wires are blue, so don't mix them up, for God's sakes. Jeez, I don't know how that's supposed to work. But then notice we have another section of the primary, and it's connected to the cathodes. The split is going to be something like 8-to-1. So there's not much of the load being borne by the cathodes, but what this apparently does, after reading up in Morgan Jones a bit about what this is all about, this is similar to what Macintosh does. It's similar to the Quad 2 from the UK. Not super similar, but and Macintosh took it a whole other level where they made the loads on the cathodes and the plates, I think, equal. But here is more like the Quad 2, where the load of the cathode is much smaller. And what this apparently does is introduce some series feedback, and it's particularly effective, I think, at eliminating third harmonic distortion. or reducing third harmonic distortion. Past that, we got some stuff I really haven't quite figured out yet. That damping factor potentiometer, the Z-matic switch. So that damping factor pot also has a switch on it, which I think must close that switch so that, so if we turn it all, I'm figuring, okay, we're turning it all the way down here, and then at the end, switch this to ground. I'm not sure what this is all about. Okay, I just haven't studied up on it. And then over here, we've got the impedance selector switch, which has a couple 1 ohm 5 watt resistors. There's also an 82 ohm 5 watt resistor, or no, that's the 0.82 ohm 5 watt resistor that I noticed before. And so by, messing with these switches, we have different amounts of resistance between the common here and ground. And then the power supply is pretty standard. There's our rectifier, our high voltage, 6 volt supply, 5 volt supply. There's no choke, so it's CRC filtering. But unlike an amp I worked on recently, those Altex took their high voltage right off of that point right there. Whereas this amp puts it through a capacitor, resistor, capacitor, filter, stage, where it takes off the 470 volts for the anode. And then 370 volt source for the driver, and then 330 volts for the AF amp and phase inverter. That's a neon bulb, so that's our power light. So that'll come on slowly. That will only come on after the various capacitors charge up to bring the voltage up enough here to sink some current through that bulb. So when that bulb comes on, that essentially tells us the amp's warmed up. We've got high voltage at the input. That's kind of a cool little bit. And yeah, that's about it. I mean, of course it's got global negative feedback here, but this whole damping factor pod is messing with that a bit. And like I said, I'm not familiar with that sort of circuit, so I can't really, not going to try to explain it on the fly. It talks about the phase inverter balance adjustment. That'll be useful to know. Nicely annotated schematic here. It's got our pin voltages. No, not voltages. Got our resistance readings for the pins of the various valves. I wish I had voltages, but actually we don't need that table because the schematic is well labeled with voltages on all the pins, which I really like to see. That's tremendously helpful. It is, you will note, cathode biased, although it's got the weird, cathode loaded or transformer loaded cathode, or cathode loaded with the transformer. I don't know. Anyway, of course it does go through, still there is a 240 ohm resistor bypassed by 50 microfarads here. Notice that's a 10 watt resistor on that cathode. It's holding that up at 35 volts. 35 squared divided by 240. Now that's always the thing with cathode biased output stages, is that resistor on the cathode needs to be pretty high power and it gets pretty dang hot. So this thing here is a suite of high powered resistors. So we've got something like 1 ohm here, 1 ohm from here to here, about 1 ohm from here to here, but 240 ohms here and 100 ohms here. And yeah, I haven't seen anything like that before. Pretty neat. So yes, the 6P3S-E is effectively equivalent to the 6L6G or GC output beam tetrode tube, and you can see that it is relatively inexpensive. That looks pretty much exactly like the one we have. They also have one down here on sale for $8. So these are low-cost equivalents to 6L6s. So I was powering this one up. This is supposed to be the one that's in good working condition. Put it on the dim bulb tester first, everything seemed fine. And then I put it on regular mains power, and the rectifier started going nuts. Started seeing glow in there, and eventually I saw it flashed. And that can't be good. I think that means it's arcing. Why do I need to show it? Because I need to see this on camera. Yeah, pretty sure that's not good. Pretty sure that means that's a bad rectifier. And this was supposed to be the good one. I'm going to try the other one. I put it on the dim bulb tester already and it seemed fine. Looking really good so far. No fireworks. The heaters are going on all the tubes. So I suspect a cold solder joint in there somewhere. Probably either right at the output or right at the input. If it were something in between, the signal would get distorted rather than go out altogether. Well, we're looking at both input on B and output on A, and I keep pushing on stuff, and I'm trying to be careful when I push on a thing to not hit anything else. So like putting steady pressure on something. Now I can't reproduce the fault. Previous time I just literally like touched the scope probe and the signal went out. Leading me to believe, well, could it be the scope probe? So, you know, like, I mean, yeah, I can mess with it, but doesn't seem to be having any particular effect. And I'm like pushing on that one resistor that seemed to be the issue before. Nada. The voltage here is slightly lower just because I was fussing with the volume pot there. You know, trying to jiggle that a bit and see if that might do something. It's like I don't want to mess it up, but it sure is frustrating when faults are not reproducible. Hey, you know, it's possible that by shoving on that resistor, I fixed it. If I can't reproduce the fault, I can't fix it. Well, I'm not sure what I should do, but I think what I am going to do, and I have turned it off because it was just getting too hot to touch even, is because most of the time the faults, and this is great, most of the time the faults appeared when I disturbed this group of resistors here. And because it is possible that my shoving of them has at least temporarily fixed the issue, I am going to desolder these joints and on the corresponding ones on the other side, resolder with new resistors, at least for these 4 here. While I'm at it, I might desolder more joints. Previously, when I retouched the joints, I didn't desolder them first, and that they do say really you ought to desolder rather than just put on new solder. Well, this is interesting. I don't know if this could be the issue, but when I desoldered this joint and then pulled at the wire a little bit, it just came broken and broke right off. So, I don't know, maybe that's the issue? Well, we're back, and it was quite an odyssey, but turned out, of course, to be one simple thing that just took a while to find. At first, I was seeing that out of the inverter, which is right here, the plate side of the inverter was giving me a very small signal. And that seemed to fix itself at some point when I messed with that joint right there. But then it wasn't good. That having been the problem at some point, I just was kind of dogged at it, and I even wired up another socket and connected all those leads to the leads on the existing socket and put the tube in this socket, and the problem remained. Well, then I started looking around and measuring stuff, and I noticed that between here and ground there seemed to be very little impedance when measured at 1 kilohertz or 120 kilohertz, although the impedance was a little bit larger at 120 kilohertz. And then I checked the other side of the coupling capacitor over here, and there was again very low impedance to ground, to the bottom side of this capacitor, I think. On the other side of this capacitor, on the other side of the board, is a 470K resistor. I disconnected that. It was fine. So I finally started looking at this connection down here and basically found that it was grounded. And so then I just undid the connections to it, or started undoing the connections, and it turned out to be the first thing that I checked, which was this wire right here, which has to go underneath that board from the other side and connect up to that eye thing. And you can see the brand new bright green wire there now. So this was effectively grounded. I don't see even now where the insulation has been, say, melted through or anything like that. I don't see anything wrong with this old wire, but replacing it fixed the problem, and now I've got a cool 25 watts. You know, we see a real nice 14.2 volts there, and that is 25 watts into 8 ohms. And up here, that's the input signal. That's the output. Looking beautiful. This damn wire. And I would say, oh, I must have messed it up, and maybe I did do something when I was resoldering the joints and so on, trying to find that old problem. Maybe I did something to its insulation, but again, I don't see any problems with it. You know, it had to go under there, and it had to go under this board, so between the chassis and the board to get to its connection point. And it was shorted to the chassis, I guess. You know, like I said, I still don't see a problem with the wire. Evidently there was one. For now, let's be happy that we've got 25 watts. So now I am back to checking the balance, or setting the balance, for the phase inverter, or the phase splitter. And that's done via that pot right there. And I've got it pretty much exactly as well as I can, but let me explain before I show you the scope. So I have got the scope probes each on the inputs to the driver stage. So I'm looking at pin 7 and pin 2 of this valve number 2, the 12AU7. That's receiving the signal from the phase splitter. And then I'm adjusting this pot here to make sure the balance is correct. I'm feeding in one signal, and what I want is two identical but opposite waveforms here at these two pins. So that's what my scope probes are attached to on the other side there. And here we go. Now I'm looking at 3 signals here. I'm looking at A and B from my probes. And one way to do this adjustment is simply to look and make sure that those 2 voltages are the same. The other is to do the mathematics and look at A plus B, because you should get 0. Now, it's not exactly 0, because partly there's a bit of phase difference. It's kind of interesting that the peak in the difference is at the crossover point. But that's about as close as I can get it to 0. And likewise, the 2 signals looking the same. And so those are the 2 ways you could go about doing it. Part of the problem with using the mathematics, the A plus B, is that it never is quite flat. So as long as I can get these 2 numbers to be the same, then I should be good. You might recall that we had some sparklies going on with the rectifier tube for the other amplifier. And so I have taken the rectifier from the one that I've just finished working on, taken out the old rectifier from the other one, and put the rectifier from the good one into where the bad one was. So the good news is no sparklies. And I put in a signal and I turned it up and I was getting about 24 watts as I should, and I was literally setting up the camera to show you when the sound cut out. And now I'm getting nothing while I am feeding in signal. Wow, man, I thought I was gonna be done with these things. Man. What happened? I was going to be so excited if the only problem with this one was the rectifier. Dang it. So I turned it off and now I've turned it back on. And now it's working again. I didn't touch anything the first time. And so I'm suspecting that the problem has to do with something thermal, something that expands, probably another bad joint. It's the kind of thing that played at low power for long enough might never surface as a problem. But I'm going to turn it up to full power, see if I can catch the failure on camera. So we're getting 14 volts. I haven't done the math whether that's 24 or 25 watts. We can hear the hum of the heater coils. Those are up there. Let's see if it just stops again. As you can see, there's no sparklies in the rectifier, so that's good, but we're looking at the output and hearing the output. And I'm being very careful not to even touch the bench, because I want to see if this is just something that happens when it gets hot. I hate it when failures aren't reproducible. The failure with the previous amp wasn't reproducible when I started. Come back later and you'll let me know if it fails, right? Right? Okay. Still going. Man. Dang, still going. Well, that's a dilemma. I I'm gonna cut it off here. Open it up and I'm not getting anything. At first I was getting about 100 kilohertz small amplitude oscillation at the output. I went and poked around over here and pushed on that one, the one that connects, you know, whatever. and that made the oscillation go away. But it still got no signal, or maybe a very low amplitude signal. Distorted as hell. Alright, so coming over here, check some, didn't get anything from the phase splitter side of the input tube. And so, yeah, I looked at so this would be the cathode output. This would, see, 6, yeah, 6 is the plate. Nothing on either spot. Check the voltage here, which should be like 190 volts, but it has a 330 volt supply. But you know, if that triode is drawing current, then across the 100K resistor, which is maybe on the other side, should be like 190 volts. But it was 330 volts, so indicating no current going across, well, basically no current going through the tube, and therefore none through this 100K resistor here. And check the voltage on pin 8, right, which should be sitting up at like 70 volts. And its voltage was 0. Or maybe a millivolt or 2. Maybe. So again, if there is, you know, the thing that makes this sit up at 70 volts is current going through these resistors, or essentially that way, and current means a voltage drop, and so, you know, get 70 volts. But if there's no current, then that would just be floating, and either, you know, would it be a ground? Yeah, I suppose. I mean, there's really nothing else for it to be at. Yeah. So, the fact that I'm getting 330 volts here would indicate that the 100K resistor here is fine, or at least not no broken connection there. And that what I need to look at is what's going on here. You know, has the phase inverter balance thing, is that something wrong with that? Or something wrong with this resistor? Probably nothing wrong with the resistors, since I have been able to get nice full power signal out of this amplifier, except sometimes not. So I'm suspecting, you know, maybe the wire going from here to here, some of these connections might be bad. So we'll be looking into that, and I will essentially, I think the task is going to be to suck the solder off of maybe all of these connections and resolder them, and actually maybe just go ahead and replace this wire, because I'm seeing here that wire there is scorched. Don't know if, you know, I mean, that may just be nothing. Other thing to suspect is this balance pot, the phase inverter balance pot. If the wiper has an intermittent connection to the wafer, that could be the source of the problem. So I'm going to go ahead and get some deoxide in there and work that pot. And, you know. Well, here we go. What did I do? Well, I narrowed it down to, it really had to be the connections between the pins of the tube and the socket thingies. So, took out the tube, turned it over, not in that order maybe, and stuck my sharp tweezer things in next to the pin socket thingies. So here's a partially dismembered tube socket, and you can see the metal bits in there. Here's one of those metal things, and you can see on the end it's got part of the metal that is bent together. You stick a pin of the tube in there, and that's supposed to make a good connection. But if it gets all stretched out, then it won't make a good connection. So you can go in next to the pins and sort of try to force them into a tighter bend so that it will make better contact. And that's what I did with all the pins for that tube. And indeed now we have signal where we had none before. And so now we indeed have signal where we had none before. And that was the one thing that I changed. And it makes sense as an intermittent failure, where, you know, okay, maybe the pin will make good contact, but yeah. And what's a little curious is that I did try sort of moving the tubes around and just couldn't get it to work. And now it does. It also makes sense that as the amp heats up, it might lose contact as the little pins expand. As the metal expands, it might expand past where it makes good contact with the pin. Yeah. But now we're getting a good 24 watts. Now, what's the ultimate fix of this problem? Well, the ultimate fix is replace the old tube sockets with new tube sockets. But, you know, it's a lot of work. And maybe we won't want to do all that. So, chances are pretty good that we can get by for a long time with maybe every once in a while needing to make those pins a little tighter. At some point it won't work, but it'll work for a while, you know? And maybe it'll work, you know, forever. If we never take that tube out and just leave it the way it is, maybe it'll be good for all time. You know, the more we sort of shove tubes in and out of there, probably the more it's going to tend to push those contacts apart. So I was sure I'd fixed it. I took out the 5V4 and swapped in a 5U4. That's the one on the left, because I wanted to be able to test the amps, give them a sound test together at least. And I did that, and it didn't work again. So I did something. I connected up this tube socket, something I'd done trying to fix the other amp, in case, you know, again, if it's the tube socket, that is, the pins aren't making good contact with the socket thingies, then this will fix it. Because now I've taken a good tube socket, which is really tight, put the tube in there, soldered wires to all the, you know, thingies, pin socket thingies on the other socket. And that works just fine. Oh, man. So it would seem that I need to replace that socket. It's just not going to work reliably. Well, another round at those pins and I got it working again. I just don't want to have to change this socket. It's I mean, the sockets I have are meant for under mounting, not on top mounting, and these are top mounted sockets. You know, I could get it to work, but friggin' drilling out rivets and the whole bit, and then it would be kind of a bit of a kludgy, not super neat repair. I just don't like it, but don't also like having it be so friggin' sensitive to... But I think this is how it's going to be. So, just after bringing them out here and hooking them up, I still had to mess with one of the pins on that one to get it to play right. But I think well, I hope you enjoyed my little tour of the Fisher monoblocks. You know, once I finished those and I let Jeff, the owner, know, he came over quick fast and got those, so I can't even include them in the shot. I've got another thing on my bench now, which is my Phase Linear 200, which blew a fuse. So I'm just going to give it a rundown. But I don't know, maybe that's another video. Maybe it's not worth a video. It's not part of this video, except to say the Fishers are gone. And I got them working. Knock wood. Jeff won't have a problem with them. He'll probably have to fiddle with that one pin socket thing. And if it just really stops working for him, then we can replace that socket eventually. But anyway. Hope you enjoyed the video. Hope you got something out of it. I think it was kind of neat just to see these old monoblocks, you know, 24 watts each or 25 watts each. Monster output transformers, so their bass was really pretty kicking. They bump. If you enjoyed the video, give it a like. Subscribe to the channel, leave a comment, do all that stuff. And I hope you'll tune in again, and if you do, I will talk to you later. Cheers.